In problem 29, we'd like to plot these points on the coordinate plane, and if they form a straight line, identify the equation of that line. So the first point in our table has an x-coordinate of -1 and a y-coordinate of 8. And then we see 2 and 3.5, 3, 2, 5, -1, and 8, -5.5. Looking at those points, it does seem possible that they might form a straight line. If they do, the slope between any two of the points has to be exactly the same. So let's focus on the slope between these 2 points. Since I'm just moving 1 unit horizontally, the vertical change is the slope. So we're moving vertically from 3.5 down to 2, which means that the slope is -1.5. Or as a fraction, we could say -3/2. We can see that slope repeated between the next 2 points. Going over 2 units to the right takes us down 3 units. And again, going 3 units to the right, 3 times 1.5 is 4.5, and that's the vertical change there. And likewise here, going 3 units to the right from that first point takes us down 4.5 units. So indeed, these 5 points are all on a line together. So let me sketch a line between them all. To find an equation for this line that's in slope-intercept form, I need to identify the y-intercept. So with this graph, I can kind of do it visually. Going from -1 here to the y-axis takes me from 8 down 1.5, so this must have a y value of 6.5. And I can confirm that going 2 units farther takes me down 3 units to 3.5. So the equation for the line must be y equals -1.5 times x plus 6.5. Of course, we could express this also with fractions. Y equals -3/2 x plus 13/2. So that gives us an equation for the line. Either of these gives us an equation for the line. The points are indeed on a straight line. Of course, there is one last way we could check to make sure our equations were true. Going back to the table, I could plug each x value into one of those equivalent equations and see if the y value turns out to be what it should. If I plug in -1, I get 3/2 plus 13/2, which is 16/2, which equals 8. If I plug in +2, I get -6/2 plus 13/2, which equals 7/2, which is 3.5. Plugging in 3, I get -9/2 plus 13/2, which equals 4/2, which equals 2. Plugging in 5, I get -15/2 plus 13/2, which is -2/2, or -1. And finally 8 gives me -24/2 plus 13/2, which equals -11/2, or 5.5. I'd like to highlight an important idea that came up in this example. The slope of a line is a constant characteristic of that line. Any 2 points on a line can be used to calculate the slope because that slope number will be the same between any 2 points on a straight line.